Good morning to everyone. So, in the last class, I gave one problem. It's a practice problem. So I don't know whether you solve that problem, but again I want to discuss that problem with you. So just I will write the problem now. Suppose if you all of you solve the problem, then I will skip. So given y dash is equal to 1 minus y and y of 0 equal to 0. And y of 0 equal to 0. Find y of 0.1 by Euler's method. By Euler method. Subdivision 2. Y of 0.2 by modified Euler method. Then subdivision 3. Y of 0.3 by improved Euler method. And y of 0.4 by Milne's method. Milne's method. So I'll write the solution. So Euler method formula. First you should know the formula for Euler method. yn plus 1 yn plus 1 equal to yn plus h into f of xn comma yn, where n varies from 0, 1, 2, 3 and so on. Now I need y of 0.1, that is y1. Now substitute n equal to 0 here. If I substitute n equal to 0, we will get y1 equal to y0 plus h into f of x0 comma y0. So y0 from here, from this we have x0 equal to 0 and y0 is also 0. So 0 and h is here 0, 0.1, 0.2, 0.3, 0.4, so h is 0.1. And we know that f of x comma y, f of x comma y equal to 1 minus y. So f of x naught comma y naught is f of x naught comma y naught is 1 minus y naught. Since f of x comma y equal to 1 minus y. Okay, now this is equal to 0.1 to 1 minus y naught. Y naught is again 0. So you will get 0.1. Okay, so y1 equal to 0.1. Next, write the formula, general formula for modified Euler formula. By modified Euler method. So please check the formula. I will write here. You also verify. yn plus 1 equal to yn plus h into f of xn plus h by 2 comma yn plus 1 by 2 into h into f of xn comma yn. So now substitute here. I need to find y2. So that's why I'm going to substitute n equal to 1 here. So y2 equal to y1 plus h into f of x1 plus h by 2 comma y1 plus h by 2 into f of x1 comma y1. Okay, now this is equal to y1. What is y1? Just now we got y1 equal to 0.1. H is also 0.1. 2. So here I don't write the values of x1, the h, y1, h, because I know that f of x comma y equal to 1 minus y. So I will take this is x, this is x, this is y. So f of x comma y equal to 1 minus y. This is y. So y1 plus h by 2 into f of x1 comma y1. So this is 1 minus this is y. Since you can write f of x comma y equal to 1 minus 1. Okay. Now again to simplify further, 0.1 plus 0.1 into 1 minus y1. Y1 is 0.1. Y1 is 0.1 plus h is also 0.1 divided by 2. And f of x1 comma y1. F of x1 comma y1 is 1 minus y1. 1 minus y1. Bracket is here. So this bracket and then this bracket. Okay. Now I think you can do in your calculator. I need the final answer. So please tell 0.1. This is plus 0.1 divided by 2. This is 1 minus 0.1. So yeah, please do it and tell the final answer.
Zero 0.1955.
0.19.
1955.
0.1955. Okay, any other answer? Thank you.
0.1855.
I got this answer. Okay, the book
Yes,
answer is
sir,
also
0.1855.
that's why I write here. So because sometimes in the book also there is a printing mistake. So I think at least two or three students got this answer. I will write here. Okay, 0.1855. Okay, thank you for your answer. So next we got y2. Next we need to find y3 using improved Euler formula. Improved Euler method or formula. Okay, so general formula is what? yn plus 1. So please verify it. So you should remember these formulas in the final exam. So yn plus h by 2 into f of xn comma yn xn comma yn plus f of xn plus h comma yn plus h into f of xn comma yn. So here I have bracket. I need to close this one. And then for this bracket, I need to close it here. And then for this bracket, I need to close it. Okay. So now n equal to 2. So y3 equal to y2 plus h by 2 into f of x2 comma y2 plus f of x2 plus h. x2 plus h is x3. Okay. So this is actually x2 plus h, but x2 plus h is nothing but x3, and then y2 plus h into f of x2 comma y2. Now this is equal to, what is y2? y2 is 0.1855. 0.1855 plus h is 0.1 divided by 2 to f of x2 comma y2. F of x comma y is 1 minus y. So f of x2 comma y2 is 1 minus y2 plus f of x3 comma y2. Okay, again f of x comma y. f of x comma y is 1 minus y. What is y? y2, y2, I'll put a bracket here, 1 minus y plus h into f of x2 comma y2. Now 0.1855 plus 0.1 divided by 2 to 1 plus 1 2 minus y2 minus y2 minus 2y2 minus minus h into f of x2 comma y2. Again, f of x comma y is 1 minus y, so h into 1 minus y2. So this is equal to 0.1855 plus 0.1 divided by 2. Here h is what? Okay, so you can directly substitute here. Otherwise, 2 minus 2y2 minus h minus hy2. Okay, so I think you can tell the answer now. Just I'll write here. Substitute the value of h and substitute the value of
0.2628.
yeah 0.26.
0.2628.
Yes, correct. 29. This is the book answer. Or you got okay? I think you got the same answer. If you got the different answer, you can tell to me. Okay, now we got y1, y2, y3. Now we need to find y4 by using Milne's method. So first, by Milne's we need to use the predicted formula. Y n plus 1 comma p, which is equal to yn minus 3 plus 4h by 3 into 2 into yn minus 2 dash minus y n minus 1 dash plus 2 yn dash. Okay, now we need to substitute n equal to what? 3 because I need y4. So y4 comma p, which is equal to y0 plus 4h by 3, 4h by, this is 3, into 2 into y1 dash minus y2 dash plus 2 into y3 dash. So we need y1 dash, y2 dash, and the y3 dash. So if it is a bigger function, so if it is the function f of x comma y is here just 1 minus y. So that's why I am going to do it here itself. If it is a bigger function, you should calculate the values of y1 dash, y2 dash, y3 dash separately, and then you should substitute here. But here there is no need. That's why just I am going to substitute here. So y0 is 0, h is 0.1 by 3 into 2 into y1 dash is nothing but 1 minus y1. Similarly, y2 dash is nothing but 1 minus y2 plus 2 into y3 dash is nothing but 1 minus y3. because we know that f of x comma y, that is dy by dx, y1, okay, it is given here, the question, okay. Here y dash is equal to what? Y dash is equal to 1 minus y. So now this is equal to 4 into 0.1 divided by 3 to 2, 4. Take that long until 4 minutes. Okay, 4 into 0.1 divided by 3. Here have 2. Okay, so 2 plus 2, 4. 4 minus 1, 3. Okay, minus 2y1 minus 2y1 plus y2 minus 2y3. So this is equal to, now we should substitute y1, y2. You know that y1, y2, y3. Please tell the final value.
0.32796.
0.32796.
796 up. 0.32796. Okay, so book answer is 3280. Okay, so I think all the same. If you take 4 digit, okay, so 327980. I think they converted into 6th coming here, so that's why it is 80. Okay, even you can write 3279 or 3280. Now I need to go for y4 character formula. Okay, character formula is yn plus 1 comma c is equal to yn minus 1 n minus 1. We check it h by 3 yn minus 1 dash plus 4 yn dash plus yn plus 1 dash. Okay, now here I need to substitute n equal to again 3. So y4 comma c, which is equal to 3 means y2 here plus h by 3 y3 dash, sorry, y2 dash plus 4 y3 dash plus y4 dash. So only thing I need to find y4 dash. So y4 dash, if it is a bigger function, so then you need to do it separately. But here the function is very just 1 minus y, so that's why I do it here itself. Okay, now y2 is it is 0.1855. 0.1855. H value is 0.1 divided by 3. y2 dash is 1 minus y2 plus y3 dash is 1 minus y3. y4 dash is 1 minus y4. Here you need to use the y4 value, this value, that is y4 comma p. You should use this value. Close the bracket. So it is equal to 0.1855 plus 0.1 divided by 3. So 456 minus y2 minus 4y3 minus y4. y4 is nothing but y4 comma p. So I need the final answer.
0.333.
Okay, 0.3333. Okay, thank you. So this is nothing but v of 4 comma c, or you can write v of 0.4. Okay, so the problem is over. Now I will give one or two problem for practice to you, so you can do it because this method is also important method. So just practice this problem. So dy by dx dy by dx is equal to 1 by 2 into 1 plus x square y square and y of 0 equal to 1, y of 0.1 equal to 1.06, this is 0, y of 0.2 equal to 1.12, and y of 0.3 equal to 1.21. Evaluate. Y of 0.4 by millions by Milne's predictor character method. So I think here what is given? Given x0 is 0 and the x1 is 0.1, the x2 is 0.2, x3 is 0.3, and the x4 is x4, I'll write here, x4 is 0.4, this is 0.3, this is 0.4, and correspondingly y0 is 1, y1 is 1.06, y2 is 1.12, and y3 is 1.21. So only thing you need to find y4. So there is no need to find the y1, y2, y3. So in the previous two problems, we find y1, y2, y3, but it is given in the question itself. So it is enough to find y4 only by using Milne's predictor corrector formula. Just I will give the answer also. You can verify. I'll give the answer. Y 4 comma y4 comma p equal to 1.2771, and the corrector formula y 4 comma c equal to 1.2797. Okay. So Milne's predicted character formula is over. I think last class I gave one more problem for practice problem. I think using Taylor series. Just I will read the problem. Okay. I think I gave this problem. Determine the value of y of 0.4 using Milne's method given y dash is equal to xy plus y square and y of 0 equal to 1. Use Taylor series to get the values of y of 0.1, y of 0.2, and y of 0.3. Okay, once you got y of 0.1, 0.2, 0.3, and then using Taylor series, you need to find out. And then y of 0.4 using Milne's method. So you try and get the answer. Okay, so for that problem is also, if you need the answer, I will tell you later. First, you will try. Okay. Now, I think after Milne's method, there is one more method, Adams method in the book, but I thought that that is included in the syllabus. But Adams method is not in your syllabus. So that's why I don't want to take it now. It's not in the syllabus. So first, I will cover the syllabus first. And then next section is numerical solution of partial differential equation. So this is the last section, the third unit. So I think it is visible to you.
Yes, sir.
Okay, thank you. So this is some general introduction about PDE, classification of partial differential equation of second order. So this is the most general linear PDE of second order. Okay, so this is the general form of a linear partial differential equation of the second order PDE. A into dou square u by dou x square plus b into dou square u by dou x dou y plus c into dou square u by dou y square plus d into dou u by dou x plus e into dou u by dou y plus fu equal to 0. In short form, a uxx b uxy plus c yy plus d ux plus e uy plus fu equal to 0. Where a, b, c, d, e, f are functions of x and y. So this equation 1 is said to be elliptic at a point x comma y in the plane if the discriminant, that is b square minus 4ac, b square minus 4ac should be less than 0. If it is less than 0, this equation is elliptic. B square minus 4ac is equal to 0, then we say that this equation is parabolic, and b square minus 4a is greater than 0, we say that it is a hyperbolic. So if it is equal to 0, you should remember like this. If it is equal to 0, it is parabolic. Less than 0, elliptic. Greater than 0, hyperbolic. Okay. Okay. But the same differential equation, the same partial differential equation may be elliptic in one region, okay, and parabolic in another, and hyperbolic in some other region. For example, you can check it. X into, this is x into uxx, x into uxx plus uyy equal to 0. So here you can see that a equal to x. A equal to X, and C equal to 1, and B equal to 0. Okay, so B square minus 4AC. B square minus 4AC. So what is B square? B square is 0 minus 4AC is X. Okay, so minus 4X. You get minus 4X. So this elliptic, when it is elliptic, because the discriminant should be less than 0. So when X is positive, you will get a negative value. So it is elliptic if X is greater than 0. Okay. Similarly, it is hyperbolic when it is hyperbolic. This should be positive. When this is positive, when X is less than 0, this is positive. So it is hyperbolic if X is less than 0. And when it is parabolic, B square minus 4AC equal to 0. When X is equal to 0, this is 0. So the same equation is elliptic in some region, hyperbolic in some other region, the parabolic in some other region. This is some examples. Elliptic type. What are the elliptic type and parabolic type, hyperbolic type? So examples of elliptic type is Laplace equation in 2 dimensions. I think you studied in Laplace equation the second semester. The third semester also you studied. It is uxx plus uyy equal to 0. That is dou square u by dou x square plus dou square u by dou y square equal to 0. That is elliptic equation, elliptic type. So you can verify that. Uxx, this is uxx. So A equal to 1. A equal to 1. And C equal to 1. C is also 1. So A is 1, C is 1, and B is 0. So naturally it is less than B square minus 4AC is 1, less than 0. So you can see that the Laplace equation is elliptic type. Similarly, Poisson equation, dou square u by dou x square plus dou square u by dou y square equal to function of x comma y is also elliptic type. And the parabolic type. So one-dimensional heat equation. I think you studied one-dimensional heat equation in Fourier transform. Okay, this is dou square u by dou x square equal to 1 by alpha square into dou u by dou t. So one-dimensional heat equation is parabolic type. And then one-dimensional wave equation. I think this is the hyperbolic type. Dou square u by dou x square equal to 1 by alpha square into dou square u by dou t square. Here you have dou u by dou t. Well, here you have dou square u by dou t square. Okay. Now we are going to discuss only about elliptic type only. Elliptic type Laplace equation, and we are going to solve the Laplace equation and Poisson equation. Only we are going to concentrate only these two. The remaining two is not. We are not going to concentrate here. And elliptic equation. So elliptic equation. Just now I told that Laplace equation is the elliptic equation. So this is a Laplace equation. Dou square u by dou x square plus dou square u by dou y square equal to 0. In short form, you can write del square. Del square is what? So you know that del square. So dou square by dou x square plus dou square by dou y square. Del square u equal to 0, or uxx plus uyy equal to 0. Okay. So now I'm not going to concentrate to the derivation. Okay, just directly I'm going to take the formula. So ui comma j equal to 1 by 4. Even if you forgot this formula, you can solve the problem. I will tell you later. Okay, ui comma j equal to 1 by 4 into ui minus 1 comma j plus ui plus 1 comma j plus ui comma j minus 1 plus ui comma j plus 1. So that is the value of u at any interior point is the arithmetic mean of is the arithmetic is the arithmetic mean of the values of u at 4 lattice points. Two of them are vertically just above and below, and the other two in the horizontal line just after and before this point. Okay. So first you can look at this diagram. So I am going to find ui comma j. So ui comma j. I am going to add these 4 values and divide by 4. That's all. 1 by 4 into u I minus 1 comma j. So because this is u I comma j means the left hand side u I minus 1 comma j, the right hand side is what? U I plus 1 comma j. So u I plus 1 comma j. And then plus here u I comma j plus 1, here u I comma j minus 1. So first I will write this one and then write u I comma j minus 1 is j minus 1 plus u I comma j plus 1. Okay. So the same thing is also here in the grid u I comma j. So here u I minus 1 comma j, here u I plus 1 comma j. So the value of this is equal to I should sum of these 4 values divided by 4. So the length is here in h. This is also the length is same. Okay, here also h. This is also h. This is also h. Okay, so this is called standard. This is called standard 5-point formula. So in short form, SFPF. Standard 5-point formula. Okay, this is the schematic diagram. So here it is. I think it is not visible. Okay, I'll read it. Central value is equal to average of the other 4 values. So that's why I told here. Okay, I think you don't have any doubts in this formula. This is a standard 5-point formula. So the next one is a diagonal 5-point formula. Okay, the previous one is standard 5-point formula. The next one is diagonal 5-point formula. The same thing. Okay, here u I comma j, but diagonal version. So here you know that here what u I comma I minus 1 comma j here. So just above is what u I minus 1 comma j plus 1. Okay, so the value of u I comma j is sum of these 4 values divided by 4. So that is given here. This is a diagonal 5-point formula. So u I comma j equal to u I minus 1 comma j minus 1. You start from here plus u I minus 1 comma j plus 1, and then u I plus 1 comma j minus 1, and then u I plus 1 comma j plus 1. So this is called diagonal 5-point formula in short form DFPF. Okay. I think now you are ready to solve the problem. At least we can solve one problem. Solution of Laplace equation okay, by Liebmann's iteration process. So the name of the iteration process is Liebmann iteration process. We are going to solve the Laplace equation by using Liebmann's iteration process. The aim is to solve the Laplace equation uxx plus uyy equal to 0 in bounded square region, capital R, with a boundary capital C, when the boundary values of u are given on the boundary. or at least at the grid points in the boundary. So it should be okay. So we are going to solve the Laplace equation in bounded. The region should be bounded square region with a boundary capital C. When the boundary values of u are given on the boundary or at least at the grid points in the boundary. Okay. So this is this equation is called Liebmann's iteration process, but I'm not going to use this formula, but just you should know, okay, ui comma j power n plus 1 is equal to 1 by 4 ui plus 1 power n. N means the iteration, number of iteration. So n plus 1 iteration is depending upon nth iteration and also n plus 1 iteration. Here you can check it. If you find any mistake in this formula, you can tell to me. So I found one mistake. Okay. That's why I'm asking to you. If you found any mistake in the formula, just you can tell. Equation, this is called the Liebmann's iteration process. So this process is stopped once we get the values with the desired accuracy. Okay, to solve the 9 unknowns u1, u2, u9 from the 9 equations, we can also use the Gauss-Seidel method or any other method. Okay, so here if you see here, this is n plus 1, ui plus 1 here. Okay, I plus 1 comma j, I plus 1 comma j. It is I plus 1 issued the nth iteration. Here I minus 1. If it is I, here I minus 1 means okay, you can take n plus 1 iteration. But only thing is here you have I minus 1. Here I plus 1. So the I plus 1 iteration, I can't use n plus 1 iteration value. So this n plus 1 should come here. And instead of this n plus 1, you should write n here. But I don't use this formula. But you should know the correct one. That's why I'm asking to you. So I think time is okay. Yeah. Find by Liebmann's method the values at the interior lattice points of the square region of the harmonic function u, whose boundary values are shown in the following square. So this is the region. So boundary values are given. So the point here have 0, here 11.1, here 17. You need to find the values at this point. So 9 points. Okay. So you need to find these 9 points. So again I'll read the question. Find by Liebmann's method the values at the interior lattice points, okay, of a square region of the harmonic function u, whose boundaries or values are shown in the following figure. Okay, since u is a harmonic, it is given harmonic function u. So and hence u satisfies the Laplace equation. So that is dou square u by dou x square plus dou square u by dou y square equal to 0, the square. So let the interior values of u at the 9 grid points. 9 grid points be u1. This is u1. I'll write here. This is u1. u2. This is u3. This is u4. u5. u6. u7. u8. u9. This is u5. Now we are going to find only these 9 values. So first I am going to find the rough values. Okay, finding rough values. So I am going to start from U5. So U5. So here I am going to use because I don't know U4, U2, U6, U8. So that's why I'll go here. So here 0, here 17, here 21, here 12.1. Actually, that is here I'm using standard 5-point formula. So this formula, standard 5-point formula. So U5 equal to 0 plus 17 plus 21 plus 12.1 divided by 4. So take the calculator and tell the values quickly. I think 12.5. So if you don't get this value, you can tell. Here you can write you are using standard 5-point formula. Similarly, next U1. U1, I'm going to use here. Here you can't use standard 5-point formula because I don't know U4 and U2. I don't know U4 and U2. I know only this value 0 and 11.1. So that's why it is better to use now diagonal 5-point formula. Diagonal 5-point formula. Okay. So, but there is some disadvantage in the diagonal 5-point formula because you will get more error. Okay. So that's why usually you need to use a standard 5-point formula. Okay. In standard 5-point formula, you don't get the errors that much. So I think it is given. It is given here. I will check it first. Yeah. So it is given. The error it is given here. The errors in the diagonal formula is 4 times the error in the standard formula. Therefore, we always prefer the standard formula than the diagonal formulas. Okay, but sometimes this not if it is not possible to use standard 5-point formula, then there is no other way. So that's why I am finding the first rough values, because here I am going to use a diagonal 5-point formula. Okay, U1. What is U1? 0 plus U5. 0 plus U5 plus 0 plus 17. So this is equal to 0 plus V5 is 12.5 plus 17. Sorry, here divided by 4. I don't write. So U1 equal to 12.5 plus 17 divided by 4. So which is equal to I don't know. So 7.4 check panni go. 7.4. Here I am using diagonal 5-point formula. Okay. I think now time is nearly 9:45. So I will stop here. So just I will give the idea. Okay. For U2, which formula you should use? You should tell. Diagonal or
Standard 5-point.
can you use now? Because I don't know. I don't know now what. I know only U1 and U5. I don't know U3. Yes, you are right. For U2 standard 5-point formula you can use. You are right. But for this I don't know now. Find u. I will find u2 later. So it is better to u3. Okay. So for u3, you need to use which formula?
Diagonal formula.
A diagonal. So after u3, it is better to go u7. Okay. For u7 also diagonal. And then after u7, go to u9. So u9 is also diagonal. So next after u7, u9, next u2, u4, u6, u8. So for these four, you can use standard 5-point formulas. So we will discuss again this problem tomorrow, and then I will go to the next problem. So otherwise, you can try. Okay, you can try. This is the rough values. Next to first iteration, second iteration, you need to go. At least 2 iteration, you should go. So you can stop the values once the values are repeated. Once the values are repeated. So minimum, the book they have done it here, it is a 3 iteration. So I will tell you. So it is depending upon the problem. You can't stop in some problems in 3 iteration. It may be go 5 iteration, 6 iteration also. It is depending upon the problem. Okay, so okay. I think now, okay, we will meet again tomorrow. Thank you.